Okay, problem number 2 on 20A. I'm sure you guys are all excited. Polar curves. Been a while since we've seen polar curves. We got this circle, y equals 3. And we got another polar weird curve we've never done before, but they graphed it for us, so it doesn't really matter. It's 3 minus 2 sine theta. You could use a calculator, but I don't think we really need a calculator for this problem. The first question said find the area of that shaded region. So the way I look at it is the area of the shaded region is just quarter circle, which you could use formulas for, but that quarter circle is just 9 pi over 4. It's got a radius of 3. So then all we got to do is integrate the other curve, right? So remember, polar area is 1/2 r squared, so that's just 1/2 times r, 3 minus 2 sine 2 theta squared, and we're going from 0 to here, so 0 to pi over 2. I just dumped that on my calculator. This is separate. I probably should have done something like that, because that's not inside the integral, that's just the quarter circle. Or you could integrate the circle also, 3 from pi over 2 to pi. It's the same thing. So, quarter circle, so 9.707. Second part says find dx d theta. So remember when we do slope, dy dx, it's dx d theta over dy d theta over dx d theta, and you got that little formula, so same thing goes here. X is our cosine theta. So dx d theta is r prime cosine theta, derivative the first times the second, plus the derivative of the second, which is actually negative sine theta, times the first, which is r. R prime is just the derivative of this thing, which is negative 4 cosine 2 theta. The rest is me just plugging in values, and I got negative 2.365. Part C says the distance between the curves is changing, and find the rate at which the distance is changing at pi over 3. So distance, these are already written in terms of r, so r is the distance, right? So if you want to find the distance between the two curves, like from here to here, actually that doesn't look right, it should be on the same angle, so let's do that. From here to here, it's just the green curve minus the black curve. It's just r1 minus r2 in essence. So it's 3 minus the other one, 3 minus 2 sine 2 theta. So that's D. They asked us to find the rate of change, which is the derivative. So the derivative of this thing just simplifies, by the way, to 2 sine 2 theta. So the derivative is just 4 cosine 2 theta. And that was at pi over 3. So 4 times cosine 2 pi over 3 gives us a negative 2. The last problem says a particle is moving along this curve, that one, so that d theta dt is equal to 3 always. Find dr dt. So dr, this is r, so dr dt is just related rates problem. It's a nice way to mix in a related rates problem into a polar problem, so they can intermix these all the time. Like this really has nothing to do with polar at all. It's just a related rates problem, right? So dr dt equals the derivative, which is negative 4 cosine 2 theta times d theta dt. Theta was pi over 6. I'll just plug that in, and they told me that d theta dt was 3 at all times. Just plug in those numbers, you can see it wound up getting negative 6. So it was polar curve, but not exactly. I mean, polar area for sure. This was a little different. I don't know that polar meant anything in the rest of it, so they have a nice little way to intermix things there.